Okay, so for our final video for this section, we're going to construct polynomials with given zeros or roots, right? Zeros, roots, same thing. So for example, find a polynomial function with a single x-intercept of 3, a y-intercept of 2, and that has degree 5. Now these can be mixed up in many different ways. You just have to take the information they give you and figure out what the polynomial is. Sometimes it's a unique polynomial, sometimes there's more than one answer that are correct. Okay, so find a polynomial function with a single x-intercept of y of 3. In other words, it has a root of 3. And a y-intercept of 2, and it has degree 5. Okay, so degree 5. So here's a solution. I think I did 2 solutions for this. So note that there are many possible solutions. So from what they gave me, I have p of x equals a. A is a coefficient. It just allows you a little wiggle room to make things happen, like to make the y-intercept be 2. X minus 3 here, the x minus 3 is to get 0 of 3, x-intercept of 3, x minus 3. Then this is just something else you have to multiply it by in order to make it a 5th degree polynomial. It could just be like x to the 4th or something. It can be lots of different things. Oh, except that it's supposed to have only the x-intercept of 3, so no other x-intercepts. So q of x is a degree 4 polynomial with 0 or more x-intercepts of 3 and no other x-intercepts. So you can have additional x minus 3s here. Or you could just make it where this has no intercepts. And then, as I mentioned, the coefficient a is adjusted to get a y-intercept of 2, because that's what they wanted, y-intercept of 2, right? Y-intercept of 2. If you don't put that a in there, then it's just going to turn out being whatever it is, and you can't make it 2. So for example, I could take q, I just call this the first example, so q sub 1, I could take to be x minus 3 to the 4th. Or I could take x2 to be x to the 4th plus 1. X to the 4th plus 1 doesn't have any roots. It's shaped kind of like a parabola, but it's been shifted up 1, which means it doesn't intersect the x-axis. Right, so that's what I'm thinking there. I'm thinking visually. So my first example would, if you use q to be x minus 3 to the 4th, and that combines with this one, you get x minus 3 to the 5th. So you just have a x minus 3 to the 5th. It's a pretty simple, at least in factored form. And then what does that do? That gives you a single intercept of 3. It doesn't give you the y-intercept of 2, but it does give you degree 5. So I just need to get this y-intercept of 2. So y-intercept is where x is 0, so I put in 0 for that, and I want 2 for that, and solve for a. And then go back to this step and put in the value I found for a. So that's what I did. The y-intercept. You get this kind of ugly number, kind of, negative 2 over 243. So that's what a is. And so then I have to go back and put that into my function. So p sub 1 of x is negative 2 over 243 times the quantity x minus 3, the quantity to the 5th, right? That's kind of an easy way to do it. Another way is to use this x to the 4th plus 1, which does not intersect the x-intercept at all, so it has no zeros, no real zeros. And so that looks like this. P2 of x equals a times x minus 3 times x to the 4th plus 1. And now I want the y-intercept to be 2. It satisfies their other conditions. I want the y-intercept to be 2. And so that's where x is 0. So I put in x is 0 and put in p2 of x is 2. Okay. And then I solve for a, and I get a is negative 2/3. It's a much simpler number. That's nice. And so then I just write p2 with the known a in it now. So it's this here, and just putting the a that I computed in here. So I take the 0 out. That was just to find a, and then I put the negative 2/3 there, and I get this. So that's 2 possible answers for that question.